algebra. Today we're going to be learning how to solve quadratics using the quadratic formula. Now you've already learned how to graph, how to solve using square roots, how to factor. Today we're doing quadratic formula, and then later in the week we'll be completing the square. So awesome job keeping up with quadratics. This is not easy, so keep up the awesome work. So the quadratic formula is here, and if we were in class, you would get to hear me sing it, which is awesome, but I cannot have that out on the internet. So there is a link embedded in your form that you should watch. It is sung to the tune of Pop Goes the Weasel. It's super catchy. Sing it over and over and over again. Play it over and over and over again. Learn it, know it, love it. It's not going away. So this is the quadratic formula. Again, you need to know it. So the first thing we're going to talk about real quick today is discriminant. And we're going to talk about discriminants. We're going to practice simplifying radical expressions again, just as a refresher for you guys, and then we'll actually do the quadratic formula. So the discriminant is the value that's under the square root in the quadratic formula. So when you solve what's under the square root, that tells us how many real solutions a quadratic has, which is really helpful to know. So if we have a negative number under the square root, for example, negative 15 or negative 23, remember there's no negative number times itself, no number times itself that's going to equal a negative number. So there's no real roots when we're left with a negative discriminant. If our discriminant is 0, there's one real root, meaning that my vertex is going to be on the x-axis. Whether it's a minimum or a maximum, it's going to be on the x-axis. And last, if I have a positive number as a discriminant, such as 29, 13, 16, does not have to be a perfect square, just got to be positive. That means we have 2 real roots. So it's going to be passing through the x-axis twice. Whether it's a positive opening or a negative opening, it's going to cross the x-axis twice. So that's discriminants. You'll hear me use that word a few times throughout the video. When we get to actually solving, you guys can see what information it will tell us a little bit later. So the next thing, we need to be able to simplify radical expressions when we're solving. Sometimes when we solve a quadratic, it'll say to give your answer in decimal form, which you guys all have perfectly. Sometimes it'll say to keep it in simplified radical form, and although we've done it this year, it's been a long time, so I just wanted to show you a quick example again and have you try one on your own. So if you're keeping the answer to your quadratic in simplified radical form, you might end up with something like this. And the first step to simplifying that quadratic is seeing if we're able to break what's under the radical down anymore. So for this one, I'm going to do a factor tree for 54. And 54 can break down into 9 and 6. 9 can break into 3 and 3. Those are prime. And 6 can break into 3 and 2. Now remember, we need partners. So I'm going to have a 3 that can come outside and left inside on its own. 3 and 2 does not pair up with anybody. So we're going to have just a 6 left under the radical. So what this is the square root of 54 simplified. So I'm going to rewrite this radical expression using my simplified radical instead. So 3 root 6 over 6. Now remember, I cannot simplify what's under the radical. The value of what's under the radical is not 6. It is not 6. The square root of 6 is actually going to be somewhere in between 2 and 3, which you remember from estimating radicals, but the value is not 6, so we cannot simplify it. What I can simplify is these whole numbers. And I want to look and see what number fits into all 3 of those. And the number that's going to fit into all 3 of those is 3. So 3 fits into 12 4 times. 3 fits into 3 1 time. I'm just keeping the 6. I cannot simplify that. And 3 fits into 6 twice. Now this one out front, you do not need to write. If we were in school, I'd tell you if it makes you feel better, you can hang on to it, keep it for now. I would say just to simplify it, take it out of there. If it makes you feel comfortable, again, keep it. But the best way to write this is going to be 4 plus or minus root 6 over 2. and that would be your answer. If you typed that into your calculator and you typed this into your calculator, you would get the same decimal. Again, we're reviewing this just in case the directions tell you to keep your answer to the quadratic formula in simplified radical form. You need to know how to do this. So now I'd like you guys to try this one on your own. If you have the notes printed out, it's the one on the right. 8 plus or minus root 32 over 4. Pause your video now and I'm going to show you my work. So my final answer in its most simplified form would be 2 plus or minus root 2. If you got here, I'd say you did an awesome job. You can simplify those both. You don't need to keep it. This is the best way to show your answer. If you didn't get it, again, pause the video, go back and check out where you made your mistake. All right, finally we are on to solving using the quadratic formula. So I'm going to show you how I write these out. I have an example that's going to have no real roots, an example with 1 real root, and an example with 2 real roots. And the first thing we need to do for solving in using the quadratic formula, just like factoring, I need to have my quadratic in standard form. So for this one, I have 4x on the right. I can't have that. I need to move it over. And I move that over by subtracting 4x on both sides. And I'm going to write it in standard form, left to right, in decreasing degrees. Now that I have it in standard form, I need to decide what is A, what is B, and what is C. And I like to write that out, especially when it's new to you guys. I would jot it out first. So A here is going to be 5. That's my quadratic coefficient. My linear coefficient, or what's next to the x, is going to be -4. And my constant is -3. That's the C. C for constant. So once I pull all of that information out, I can plug into the quadratic formula. And although that formula looks intimidating, the one we looked at in the beginning of the video, it's not. You're plugging it in and you're using PEMDAS as you're solving. So I'm going to plug in, I'm going to write it out again for you guys actually before we start. -b plus or minus the square root of b squared minus 4ac all over 2a. You got a little bit of singing there. I still sing it. The song will help you, so learn it. So now I'm going to plug in over here. I have -b. So my b is already negative. I'd say that's one of the biggest mistakes. Be careful with your negatives. I like to, when I plug in, I put all of my values in parentheses because then I can tell what's going on without missing a negative. So -b plus or minus the square root of b squared, again I'm keeping in parentheses, minus 4 times a c. I'm running out of room there. So now I have it all over 2a. And sometimes I write it out at first and then I kind of lose it as I'm solving and pick it back up at the end. 2a is 5. Now I'm just simplifying. So a negative is going to be +4 plus or minus the square root. -4 times -4 is 16. And then I like to multiply these three numbers together. So -4 times 5 times -3. Well, I know a negative times a negative is a positive. And 4 times 5 is 20. Times 3 gives me 60. And this is all over 2 times 5, which is 10. Next, I'm going to simplify what's under the square root. So I'm left with 4 plus or minus the square root of 76 all over 10. And this is where this tells us a lot of information about this quadratic. This number under the root, my discriminant would be 76 here. That's a positive number. I don't care what the value of the number is for the discriminant necessarily. I care that it's positive. And what that means when I have a positive discriminant is I have 2 real roots. So I have 2 answers in this problem. And if I were to graph it, it's going to cross the x-axis 2 times. So if the problem asks me here to give my answer in decimal form, I'm set up to do that right now. All you need to do is plug in 4 plus the square root of 76 and divide by 10, and then do 4 minus the square root of 76 and divide by 10. If it's asking you to give it in decimal form, you don't need to simplify the radical. It's actually easier without it. So the decimal form to this answer, I already did it out, so I know that it's about 1.27. and -0.47. So that would be in decimal form. I rounded to the nearest hundredth. And now if it wants it in simplified radical form, that's where I need to go and do what we did before. I need to go ahead and simplify the square root of 76. So I would break that down with a factor tree. I know 76 breaks into 2 and 38. 2 is prime. 38 breaks into 2 and 19, also both prime. My 2's can partner up, so I'm left with 2 root 19. So I'm going to rewrite this radical expression using 2 root 19 instead of square root of 76. All over 10. And this is where I need to simplify what's not under the radical. I'm losing my marker here. So what fits into all 3 of those numbers is 2. 2 fits into 4 twice. 2 fits into 2 once. And 2 fits into 10 5 times. Now you don't need to write that 1. The best way to write this answer would be 2 plus or minus root 19 all over 5. And if you type that in your calculator, you should get the same answer that we got up from up here, the same decimal, so it's a good check to do. So the next problem we have should look familiar. This is a perfect square trinomial if you learned to recognize that pattern. And what that tells us is that we are going to have one root, one real root. If you don't see that right now, that's totally okay. I'm still going to plug into my quadratic formula. First, this is already in standard form, so I can just say that A is 1, B is 10, and C is 25. And then I'm going to plug into the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And now I need to simplify. So negative times 10 is obviously negative 10. Plus or minus 10 squared is 100, and negative 4 times 1 is negative 4, times 25 is negative 100. Now here I know 100 minus 100 is going to be 0, so I have the square root of 0. And I don't have my denominator, my times 2a down the bottom yet, but what that tells me, this discriminant is 0. That tells me I'm going to have one answer. I have one real root. So the vertex of this quadratic is going to touch the x-axis. Now I'm going to just keep going to solve so I can get my actual answer. 2 times 1 for my denominator is just 2. And the value of the square root of 0 is just obviously 0, so I don't need that at all. And negative 10 divided by 2 is 5. Negative 5, excuse me. So if I were to graph this, my vertex is going to touch the x-axis at negative 5. I know that that's going to be the minimum of my parabola because this is opening upward. So that tells us a lot of information about what this quadratic looks like. We have one more example. Again, I'm going to start out by pulling out my A, B, and C. This one's already in standard form again, unlike the first one, so that's a little bit easier for us to just go ahead and start. So my A is going to be 2, my B is negative 3, and C is 5. And then I plug into the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And I like to solve under the square root first. So I have 3 plus or minus. Negative 3 times negative 3 is going to be 9. Negative 4 times 2 is negative 8. Times 5 is negative 40. And what I'm seeing here, I can go ahead and stop. If this were a test, if this were classwork, a homework, hopefully you would recognize it and know that 9 minus 40, I don't care about the value of the number here. I know that it's going to be negative. So I can just stop when I have a negative square root, a negative discriminant. I'm just going to shorten that. Negative discriminant means no real roots. Now when you get into freshman year, when you get into geometry, algebra 2, you're going to be able to figure out what that means, what a negative square root means. But in 8th grade and algebra, we just say no real roots. We have imaginary roots. We're not using I. We're done at no real roots. So if you'd like to see me sing the quadratic formula, maybe come to a Zoom. If you don't want to, then definitely go on and click that YouTube link in the form so you're able to sing it and learn it. It's going to be helpful. I promise it's not going away. You will use it for the rest of your math career. I hope you enjoyed the quadratic formula. It can solve every single quadratic out there. That's what's awesome about it. And we will do completing the square next.